In this video, we are going to complete this problem 3 sum. Well, this is another problem that is asked commonly in the interviews, and this is not quite straightforward. But if you have seen my last video 2 sum, this problem might just be easy for you. So let's get started. The problem statement is like this. Given an integer array numbers, return all the triplets nums k such that I not equal to j not equal to k and the sum of all those 3 numbers equals 0. Well, if you remember the 2 sum problem, there we had 2 numbers and their sum was equal to 0. But now we need to solve the same problem with the constraint that we have to find 3 such triplets in the array such that they sum to 0. Well, if you think about it, this question is not that difficult. It is very similar to the 2 sum problem. And if you had seen that last video of mine, you would understand that there's a simple mathematical formula that you can derive from the equation to actually solve the problem. In the similar manner, we can derive the formula in this problem. So let's go ahead and understand the problem statement again. So we just have to find those 3 numbers whose sum equals 0. And if you look at the examples, we have the first array and you can see that there are 2 such triplets in the array. Well, actually, there are 3 such triplets, but the thing is that we have to identify unique triplets. We can't have repeated triplets. By unique, we mean that all the numbers, the set of the numbers in the triplet should be distinct. So we can't have that set repeating again. So in the first example, you can see that the numbers at index 0, 1 and 2 are -1, 0 and 1, which sum up to 0. The numbers at index 1, 2 and 4 are 0, 1 and -1, which sum up to 0. But you can see that the triplet of -1, 0, 1 is unique. Well, if you think about it, if we just sort our triplet, then we won't have a problem of encountering the same triplet again. Now, if you look at the second example, we can't have any such triplets in the array. And if you look at the third example, we have one such triplet in the array of 0, 0, 0, which sums up to 0. Now, if you look at the constraints, the number's length, that is the length of the array, is only 3000. And if we think about it, then n square solution should work here, and even n square log n should work too. So n square solution works, n square log n also works. And let's just think about the formula once more. If a plus b plus c equals 0, as I have written in the comments, then a plus b equals -c. If you remember the problem 2 sum, we had a similar condition. There we had a plus b equals c and a should be equal to -b. But here we have the sum equals to the negative of that number. So instead of a plus b plus c equals 0, we can rewrite it as a plus b equals -c. Now, if you just visualize the array, let's say that all these dashes are the numbers that we have already seen, and currently we are iterating over the part that is in brackets. Then if we have like I and j, which we are iterating over in the brackets, then we should have seen the negative of their sum already in the array before. So that is our triplet is found, and we just need to sort these numbers so that our triplet is unique. That is a simple condition to fulfill. So let's get started with the coding. First of all, I will just create a triplet struct containing the numbers a, b and c. I will write a function sort triplet where I will take a triplet x, returns a sort triplet. So a, b and c can be any number. It is not important that they are sorted, but the triplet that we get in return must be sorted. Or I think like this is going to be too complex, I mean unnecessary. So I would just write a sort function that takes integers a, b and c and returns 3 integers a, b and c such that a is less than b is less than c. So you can see that the sort function is very simple. I will first compare the first 2 numbers a and b. If a is greater than b, I will just swap those numbers. Similarly, I will compare a with c and swap if a is still greater than c. So now we are sure that a is the smallest number because we have already compared it with the 2 numbers b and c. Similarly, I just have to sort b and c. So if b is greater than c, then I will just swap it again. So b and c are swapped to b. So now we have this array, or we have the 3 sets of number a, b and c such that a is less than equal to b is less than equal to c. Well, I will just test this function by writing the triplet print statement in the 3 sums array, and I will return nil because I don't want any return in this case. You can see that I'm facing an error. I will just fix it. I don't think we need the brackets, so removing the brackets, this code now compiles. But you can see that the output that I got is 1, 2 and 1 instead of 1, 2 and 3, which is wrong. So I will just go ahead ahead and try to debug this. I could have done this off camera, or I could have edited out this portion, but I don't want to do that because I don't want to show my audience that I'm some magical, mystical pro coder guy who is editing things quickly. I'm not. I'm just a simple programmer. Just like you guys, I also face problems and I try to edit them online inside the video without cutting them out. Let's get started again with the coding. Okay, so now instead of like coding, I will be trying to debug this, and just like a new programmer, I will simply write some print statements to understand where we are going wrong. So you can see that it's the last part where I'm seeing as 1 to 1, which we don't want. So and you can see that I have found the problem. Instead of b comma c being solved with c comma b, I was doing c a, which is wrong. So b comma c should be c comma b. That is, we are swapping b and c and nothing else. So now we have this sorted array, we are returning the, and if I just try to print the numbers, then 1 2 3 is being printed. So this works fine. Now I will just go ahead and start coding this problem. Now I will create a mapping of triplet comma boolean. So this mapping will ensure that we have seen the triplet only once and not multiple times. I will take the length of the nums array as n, and I will just iterate over the nums. So for I equals 0 to n and j equals I plus 1 to, I will simply try to find the sum of nums I and nums j, which equals x. So now if you can see in the comments, then nums I plus nums j should be equals to minus nums k, where nums k is the number, or k is the index that we have already encountered previously. So if you just put or select the subsection of the array indicated by I comma j, then k is the index of the number which we have already seen. That is, k is seen in between 0 to I minus 1 inclusive. So we can see that x equals I plus. If we have already seen negative of x before, then we can simply take a triplet of these three numbers. Nums k is simply minus x, and I will just sort those numbers. I will take the triplet of it and I will mark it in the mapping that I have already seen this triplet. So if I see it again, it will be marked again in the map, so we don't want the triplet. And now what I will do is I will just mark this very important part that I have seen the numbers. So you can think of it like this. I am at a current index I, and I iterating over all the indexes, which equals I plus 1 n. And now when I have finished processing this index I will mark it as seen, so that when I try to process the further subarray, this index that I have already encountered before is already part of the seen array and I can take account. So I will just try to explain this once more using comments. You can see that this dashed part is the part that I've already encountered, and this part is the I comma j that I'm iterating over. So for some fixed I and j, k is the set of numbers that I've already seen, and it is already part of my map scene. So k is already seen and it is part of the mapping, and I'm just iterating over there and checking if I have seen the negative of the sum of the current number I and j that I'm iterating over. And if I then a triplet is found, I will just write a function that I did not write before to convert a comma b to triplet struct. This is a very simple function, sort of like an identity function that takes in three numbers and gives, well, I wouldn't say identity, but I would say a transformation function, which is as simple as it gets. Now the important part is that we now have an array of array. So for all the keys in the mapping, for k equals range of mapping, that is, I'm iterating over all the keys of the map. Now each key is a triplet actually. Now what I will do is I will just simply make an array which is of int comma int, which is of type array of integers, and now I will simply append the array to my return array, which is an array of array. So I will just write to array, which takes in a triplet and returns me an array. And this is a very simple function. In Go, you can just simply write the return type that you are going to return, and I will simply append all these numbers tc to the return array and simply return the array. So to array takes a triplet array, and I will simply take over all the keys of the mapping that I have already seen, which is the triplet mapping, convert them into an array, append it to my return array, which is an array of array, and simply array. Well, I have some compilation issues. You can see that it is actually minus x and not nums of k because it doesn't exist. And just to explain once more in the comments, so minus x is the number that we want because x plus minus x equals 0, and x is actually our nums I. So nums I and minus x is the triplet that we want to up to our mapping. So this is it. If we try to submit this problem, we can see that it is accepted. The runtime time is pretty high, which is 402 milliseconds, but we don't care. We just wanted to solve this problem, and this problem is solved. And we can say that we are some smart, geeky software engineers who can crack these silly dumb FAANG companies easily. So you can just go ahead and look over the code, try to understand all this, and I hope to see you in the next video.